truck would have apples and lettuce might not be the way we want to present it to our customers or our business users or our analysts. We want to make it more organized. So very similar to that, when we unload the truck, we keep it in a certain place, we quality check it, and we do all of those things. And then in the warehouse, when we go on and sorting it, apples go with apples, lettuce goes with lettuce, so that it's very easy to shop for, or very easy for our analysts or business users to use that data. So in data warehouse, you can think about there are multiple data sources coming, multiple trucks coming, and you're sorting things so that it's really, really easy to analyze. So that's the whole point of creating a data warehouse. Any questions about the basics, like why are we using Snowflake and why are we using data warehouses?
Why would this be any different from, say, SQL Server or Oracle?
So my understanding with SQL Server is, I haven't worked a lot with SQL Server, but I think they do have OLAP offerings. So I would say it's very similar to that.
Yeah, I think SQL Server uses SSAS analysis server as part of their warehouse.
So in that case, it would be very, very similar.
Yeah.
Perfect. Now, just to quickly show you how the data flow looks like when we are going into the data warehouses, is these enterprise systems. Think about these systems as your data sources. And for example, if I give you my company example, it's a real estate company, and we have customers. So customers who are trying to buy houses, we have real estate agents. So we have that data source as well. We have MLS listing. So MLS listing would be when people want to buy and sell their houses, they put it in a listing system. It's a public listing system, so people can have access with pictures and description. So we are getting all these different data sources getting into our data warehouse so that we can analyze how the market is moving, how many customers we have. Like there are so many questions that a business user would have, and we are putting all that information into our data warehouse and then organizing it, making it clean, making sure that whatever it's reporting is right, and then we let it be available for our BI layer so that we can do analysis on it. Now, here you can see some keywords, and I will just quickly touch them because we don't have a lot of time to go deeply into all of these keywords, but let me quickly touch on them. Data lake. Data lake, so what happens is when we are putting all these data sources into a warehouse, the first thing we do is we put it as it is. So we take a data source and we put it as it is. There could be a few reasons of doing it. Number one, we want to store it. So for example, a data source is, and sometimes what happens is, for example, if I think about a deal, some customer asks us some information. So they clicked on advertising and then they submit some requested some information. That thing is a stage in our sales funnel. Like this person asked us about some information. Now, when we gave them information, that person goes into a different stage. And when he's like, okay, I want to list with you guys, that's a different stage. Now, in a CRM system or the system that's keeping all this information, it only keeps the most recent information. We can figure out a way to keep the old information, but it's not the use case for it. While in a data lake, what we do is we can say, this data source came in on this date at this time, and this is all the information this data source was carrying. So we put that data source as it is, that if someday we need to reference what the state of the system was, we can easily do it because we have this all stored in one place. So that would be a data lake where we're just putting all the data sources as it is. Now, as I said, when a truck comes to a Walmart warehouse, how truck is sorted might be different than how we want to sort things in Walmart. So truck might have lettuce and apples and different type of vegetables and fruits all in one truck. But in reality, we don't want to keep them together. We want to keep them in their own shelves. And this happens with data sources as well, that our data source might come in with multiple information, having customer information, having deal information, but we want to keep it in different shelves, or by shelves, I mean tables. So I want customer table to be different. I want deal table to be different. So before putting things into my data warehouse, before putting things and getting it ready for my business users, I want to clean it, make sure that, whenever Apple goes into the Walmart shelves, Walmart says it's a good apple, like they want to sell it as a good apple, or this meets their quality. Similar to a data warehouse, we want to clean data so that any data or any data with errors doesn't go to our business users, because then they're like, okay, they will stop trusting our data and they will be like, okay, how can we use this data, because it just keeps giving us errors. So when we are putting into data warehouses, we kind of have certain zones that we deal with. And in those zones, we are just trying to make sure that our final stage is as close to the requirement that data users have, so that they can easily use the data. So here, one of the zone is called landing zone. So what's happening is we are just bringing in all the data sources, and we are putting it into the landing zone. And then comes the enterprise zone, where we are cleaning it. We are saying, oh, this row is missing date. And if it's missing date, I don't think so I should put it in my warehouse, because I don't want any data with no dates on it. So between landing zone and enterprise zone, we are making sure that our data is clean and it's making sense. For example, if the price of something is in negative, you're not giving it for free, or it's not like you're paying customers to take it. So that should be erroneous data. So we want to remove it. So we can do such cleanings in the enterprise zone. And sometimes a data source comes with, customers information, deals information, price information, but we want to keep it in different tables. And that's what happens between enterprise zone and business zone, because we know our users, when they are thinking about customers, they might be just thinking about customers. So we want to let them have a table which is all about customers. And when they are thinking about deals, they can go ahead and work on deals instead. And that's where you can see from business zone, it goes to BI layer. Any questions on why we are using what is the business scenario and what's happening when we are using a data warehouse?
I guess because all the data is common. So per business, you have to figure out what the business requires in order to extract it.
Sorry, say that again. All the data is what, sir?
I think because in the data warehouse, you have tables from everywhere. So in terms of different businesses, you have to figure out what each business requires.
Right. So yeah, in data warehouse, you can have different data sources, and we have tables from everywhere. So you have to organize it so that it's based on business requirement. You're right. Okay. So now we know kind of where Snowflake comes in. So now what I will do is I will give you a little teaser on the components of Snowflake, like how they created it, how they are thinking about it, what can we do in it. And as I am going through the components, I will just quickly go through a demo as well of those components. So I will just go into Snowflake console or use a CLI and show you, okay, see, this is how I'm creating tables and things like that. So hopefully you will find all those things useful. Okay, so the first component of Snowflake is, I think a lot of people already touched on it, is a database. So database is basically a place where you keep tables. So it's a storage space where you keep table. And in Snowflake, it's pretty easy to create a database. Now, why would I need different databases? So a Snowflake can host, I don't remember if there's a limit of number of databases can host. So it can be like millions of databases might I don't know the limit, but it could be a big amount of databases that can go into Snowflake. But can you guys think of a use case where we will need different databases? Okay. I can think of two use cases where we would need two different databases. So one use case would be, for example, if you're a consultant and you are a big consultant who deals with grocery companies. So you have Safeway, you have Walmart, you have Real Canadian Superstore. You want a certain separation between these organizations' data. You are consulting with them, they're giving you access to giving access to their data to you, and you want to keep them separate. In that case, you will use different databases to keep it so that there is just no way that if somebody have access to a certain database, they can access some other organization's information, because it's a separation. There's no way, until unless they get access to a different database, there's no way they can access the other database. So that could be a one use case where you will keep different databases separate into places, or into your Snowflake instance, there might be different databases. One more thing that is quite common in data industry and in software engineering industry is to have different databases for development and different databases for production. So you can see there is a dev database and a prod database. And the reason why we want that is because, as a developer, you are doing something. You created new tables, you are trying to test new things, you are building new things. Do you really want those tables to be exposed to your users before you are even ready? And the thing is, we don't want to do this for a simple reason, because if we give them wrong tables, the trust on our data would go down, and data trust is a huge thing. So what we do is we have a development database where we play, we make new things, we do everything. And once we get it right, then once we know that, this is how our database should be, this is how our tables look, we just clone it or push it to production. So that now your database, your new, most optimized, the way you want your database is in production. So now all the new things are exposed to the business users. Now, if we keep those databases same while you're working on something, business users can still use it, and the data trust and all those problems are sometimes what happens, you crash a database. Now your whole database is gone. But if you have this separation, it just becomes that much more easy to work on development. So those will be the cases where you can keep different databases in a Snowflake environment. Let me quickly go and show you. So firstly, Snowflake. I guess I hope you guys all know how to make a community Snowflake account. But it's pretty easy. Just go to Snowflake community account, log in, username. They send you your email updated, and then you come into this console. And let's think about how are we going to create a new database. So for example, if I go here, I can just say create database if not exist. Very simple command. It's SQL that Snowflake uses, and I'm just going to run it right here, and it's going to say DemoDB, which is the database I wanted to create, is successfully created. And when I want to use it, so instead of telling, and you will see that when I am using tables, I don't want it to don't want to say that I'm using this database again and again. So I can just say use database, and this will make sure that whatever query I'm doing, it's looking into DemoDB. So this command is just to make sure I don't keep repeating myself, use DemoDB, use DemoDB, use DemoDB. It just takes care of it. So that's one way of creating database. And you can see if I go into my databases here, I create a demo DB, so I will refresh it and you can see there is a demo DB. Whenever you create a database in Snowflake, it comes with two things automatically populated. One is called information schema. It's a place where it keeps all the records of what tables it has, and all the data about the database goes into information schema, while public schema is something that is ready for you to use if you want to use it. And we will talk about schemas in just 2 minutes so that you understand what the word actually means. Now, it's quite possible. So this is what I did is I use SQL to make such a database, but can I use console? That means, can I just click buttons and make a new database? For sure. If you go into data and databases, I can just click plus database and I can say demo DB console, for example. And I create it, and you can see that demo DB has been created. So in order to create a database, you can either write SQL, which is like create database, give it a name, or you can just go to data, databases, add a database right here. And I'm just going to drop it because I don't really need it. But Snowflake, one of the good parts of Snowflake is its console is very straightforward. But here's a question. I will show you both ways of doing things. One is a SQL way of doing things, or programmatic way of doing things. And the other way would be clicking buttons. Clicking buttons is always definitely much more easier. Why do we need a programmatic way of doing things? So why do we need code to make our databases instead of just...
If you're making 100, it's easier to write code than just clicking buttons.
It's easier to write code than clicking buttons?
If you're making a lot of databases, like making like 100 of them.
Perfect, you're right. So automation is really, really difficult when you're just clicking buttons. So code is just like super simple. And that's why whatever I do, I will give you 2 ways of doing it. But the most preferred way would definitely be to go and use programmatic way or to write programs, because it's just so much more easy and faster to do and much more potential to get automated. Okay, so we talked about databases, very simple way query, and in creation we see there's a console way of creating and there's a query way of creating. Let's talk about schemas. So schemas, so we have a division databases, so there can be millions of databases. Schema is just one more layer after database, where inside a database you can divide things. So for example, in a Walmart warehouse, schema would be produce, electronics, where you are just dividing the warehouse into more pieces. So very similar in a database. When you divide database into small pieces, it becomes schemas. Here you can see we talked about landing zone schema, enterprise zone, business zone schema. And what it means is basically from landing zone, we made a division and we say we are going to put stuff that just landed into our data warehouse right here. Then we will clean it. And once we clean it, we want to store it somewhere. We just don't want to keep changing things in the landing zone, because someday we might figure out that, you know what, our data that we cleaned wasn't cleaned. And we want that data back in a raw state so that we can start cleaning it again. So that's what we do. In landing zone, we keep all the data in a raw form. And then enterprise zone, we are already cleaned it. And we make a separate zone saying, this is a clean zone, and that becomes enterprise zone. And then when we sort data into different tables, saying customer information would go into customer tables and sales information would go into sales table, we create one more schema. Rather than losing the enterprise zone cleaned data completely, we can just make one more division, and that would be our schema for our business user ready database for data. Now, very similar to our database. Schemas are very straightforward to create. There are two ways, as always, to create a schema. One way is to just create a schema programmatically. Okay. Unable to use, compilation error. So demo DB schema create if not exist. Oh, because I think it's already there. Database says. Okay. Oh, demo DB is not there. Okay. Just quickly make demo DB again. Demo DB and use it. So demo DB is there. Now I want to create a new schema. Create schema in demo DB named schema. Object does not exist or operation cannot be performed. It is in demo DB. Let's keep it all public, and now it can create schema right there. Okay. Perfect. So pretty easy to create schema. You just say create schema if not exist, then demo db.schema. Again, with everything comes one more way of doing things. And if I go to console, go to data, database, go into demo DB, I can create schema saying schema console, for example. If you create it, you can see DemoDB has these multiple schemas now. One is something that we create programmatically, and the other one is from the console. I don't need it, so I'm just going to drop it. So that was schema. Now, one thing that we saw, and there was the console way of doing it. One thing that we saw in schema, and I was talking about it, that when you get data in your landing zone, you do some cleaning, put it into the enterprise zone. So you can think about that there should be a way to transfer data between schemas, because when you're ready, you did all your operations, you want to put it in a separate schema, there should be a way to do it. And yes, in reality, there is a way to do it. And how you do it is basically, and let's do it. So I have a schema called schema, but like, for example, let's create two schemas. One is called landing zone. So I'm just going to take this query, run it, and you will see that there is a landing zone created. And the other one is called enterprise zone. You can see enterprise zone is created. Now, I create a table in landing zone. So in order to create a table, what you have to do is say create table. If not exists, the reason why I say if not exists is because if there's a table that's already there, I don't want to create it again. So that's why this keyword if not exists comes in here. I'm going to say this table is going to be in a landing zone schema, and the name of the table would be table 1. And it would have two columns. One is column 1, which is a integer type, and column 2, which is integer type as well. So I'm going to do that, and it's going to create a table. If I go into my database and go demo DB, refresh it, you will see I have landing zone, and in landing zone I have this table, and you can see that it has two columns. So pretty straightforward, just simple SQL to create a table. Now I can insert some information into the table. Very simple, insert into landing zone table. You tell where to insert, and you put in values for it. You can see that there are two things that are inserted into that table. And if you want to see those values, we can just say, let's start from that, and you can see two values are there. Now, you said in reality, only one of those values were right. So the column first one, which is 1 and 2, is right. So in my cleaning process, I said this column 1 should only continue. Column 2 is not right. In order to transfer that data, the first thing I have to do is to, again, create a space in enterprise zone, because right now there are no tables in enterprise zone. So I will just go ahead and I will just create a table in enterprise zone. Right there, Again, the table name is table one, exact same table, just a different schema now in enterprise zone. And then I say, insert into enterprise zone, table one, take everything from landing zone, but limit one means just take the first column. And if I do that, you will see one column is done. And then if I do that, you will see that there's just one column in that zone. So basically, this is a very, very simplified example. But in reality, what I want to show you guys that if something comes with from your data source and you want to put some SQL around it to clean it and then move it to a different schema, it would be something really similar. Like this is how you would do it. It would be much more complicated query, but the language like create table if not exist, insert into would stay same. Those are your schemas. Any question when it comes to schemas? Okay. So these are schemas. Perfect. Let's talk about some more components. And you will see that these components are very similar to the components in the database. But there are differences when it comes to Snowflake and a database, and it's coming up. You will see what differences there are. Now, we had databases. Then comes schemas. So we are just dividing database into schemas. What about if you want to divide schemas into some logical unit? And that logical unit is tables. So in a table, you can have schemas. So now there's a division of schema, and in schema, there can be thousands of tables, where in a very similar way in database, there can be thousands of schemas. Now, Snowflake give you options of different type of tables and different type of views. So we will just go through them individually, think about them, what they're doing, why are they there, and things like that. So that you guys kind of have an idea of what's happening. A regular table is basically a regular table. It cannot be more, it's just a table. Like in a database, very simple table, regular table is just like a table. In order to create regular table, it's pretty straightforward. So if I go into tables and views, how you will be creating a regular table is, okay, create schema if not exist, use this schema. And this is the table I'm creating. The keyword I will be using is create table because it's a regular table. I don't need to really give anything. It will be in a schema, and I just for easy purposes, I just say how to create a table. My table name is how to create a table. It would have key one, key two, description, update time, so that, and what it means is as soon as I put in a record in it, it will just record the timestamp right there. So that's what current timestamps update time means. So I will just create this table. Pretty simple. It's compiling, successfully created. Show table. There you go. You can see that it's in schema, database demo DB, kind is a table. Pretty straightforward to create tables in Snowflake. Transient tables. Now, what happens with Snowflake, something that doesn't automatically come with other databases, is Snowflake remembers if you created a table. And even after you delete it, there is a fail-safe period. What it means, and I think it happens a lot with me, is I did create a table. I was like, okay, let's do all these queries. I did all those queries. And in the end, it wasn't matching to what I really wanted. So I'm like, okay, let's drop it. And I dropped the table. Half an hour later, I'm like, oh, that's why it's not matching. I want that table back. The problem with a lot of databases is that if I want, I cannot get that table if I dropped it. In Snowflake, they're like, why don't we give you a fail-safe period? So that if you want to run and get that table again, there is a command for it and you can do it. But we will give you this option with little bit more money because that means we are backing it up somewhere and it's costing us money. Regular tables are getting backed up, while transient tables are not getting backed up. So you're like, I really want to save money. In reality, I won't need this table. Even if I drop it, I can create it again. I don't care about this table. Save some money, make a transient table. So that's what the goal of transient table is to make sure that if you drop it, it doesn't come back. Let's quickly make a transient table. Here, I will be using a keyword called transient. Just to make a difference. And if I show table, you will see the kind of table has changed to transient. Now, Snowflake has quite a few things happening. So I will cheat a little bit in this example, but the whole purpose is to show you how would the transient table be different than regular tables. So if I put my transient table time retention equals to 0, so now if I drop my table, this is a regular table, it's successfully dropped. After a few minutes, I realize, I don't want to drop it. I want to give it a command called undrop table. So I give it undrop and Snowflake is like, oh, perfect. I successfully restored it. Now, what about if I do it with the transient table? Successfully dropped. I want it again. Oops, does not exist or purged. So basically, regular table can get back. Transient table, unfortunately, it cannot. Let's talk about temporary tables. So transient table is also cheap. So there is a balance between what you want to do. Temporary tables. Now, sometimes what happens is you're like, I want to create a table, but in reality, I don't really want it. So if my session gets over, that means if I log off, I just want to get rid of that table because, it's going to cost money if I don't get rid of it, but remembering to get rid of it before my session ends is too difficult. So why don't I give it a very specialized keyword, which is called temporary table? And what temporary table means is it won't exist as the session gets over. So let's create the exact same table, but I will change the name, how to create a table. There you go. I will show tables. And here you will see that there are two types of table right now. How to create a table is a table kind, and how to create a temporary table is a temporary kind. Now see difference in between them. So this is my session. Let's log off. Go here. I say sign out. Perfect. Let's go again. Worksheets, let's go to table and views. You will see it right here because it's just bringing in cached information. But if I run this query again, show table, gone. Temporary table is gone. Because in reality, as my session got over, the temporary table disappears. So this is just a very simple way, cost-saving way. If you know that you're creating a table that you won't need after a few minutes or an hour or after the session is done or tomorrow, but you don't want to remember deleting it. So this way you just create a temporary table, it's gone.
I have a quick question.
Yes.
So I get the temporary table, right? But what's the difference between the transient and the regular one? Because when you logged off, the transient was still there, right?
Say that again.
The second one, was that you called it transient table?
Right.
So when you logged off, that was still there. That didn't go away.
No, so this is table. Transient table, I dropped transient table in this example already. So that's why it's not there.
It would still be there.
After the session? after new session, yeah, transient table would be there. Yes.
So explain the difference between transit table and the regular table.
So it's the fail-safe period. So you cannot undrop it once you drop it.
And the regular tables you can undrop.
You can undrop, yes.
Unless you commit, I guess. All right, thank you.
Right, yeah. I don't know what you can set up the time, but it could be like 15 days, 10 days, after which it disappears. But regular table you can undrop, transient table you can.
All right, thank you.
Perfect. Any other questions on tables? Perfect. Okay, views. Now that's a database word. We have heard about views. Can anybody tell me what views is?
A custom look at existing tables.
Custom look on existing tables. Okay, that is correct. You said look. Why did you say look?
A custom, because it's you can pick and choose what two columns from here, one column from there. Because the custom look on could be based on one table or multiple tables. So you're picking and choosing what columns you want to show in your view.
Okay, yeah, sure. Yeah, that's right. When you make a view, how old is your data?
As old as the table.
As old as the table. Okay, perfect. Yes. So as Uzo said, so view is basically sometimes what happens is you want to build tables. You build a table, and then you want to combine it. And you want to custom look at like for example, you want to combine different tables and do things like that. You can do it in a simple query, or you can save that query in a view. What that means is I wrote a 50-line query. Would I want to keep writing that query again and again? 50 lines? I don't think so. So what I'm going to do is I'm going to say create view and put that 50-line query inside there. Now, whenever I say select all from this view, my database is going to run those 50 queries and I don't have to remember or write it again. So that's a good part of view. It's just like a saved query that you can query whenever. One more good part of view, which is different than a table, is that in reality, it does not really exist. What I mean by that is your saved query exists, your SQL would exist, but it's not a physical table. So because it's not a physical table, whenever you need it, it gets created brand new. So your data never gets old in a view. For example, if you remember, I did a quick example of data transit in which I insert into enterprise. I created a new table based on the landing zone schema, and I created a new table in the enterprise zone. That enterprise zone table won't change. Like, it's not like if there is a new data added into the landing table, it won't automatically get added into the enterprise zone table, because those are two different physical entities. On the other hand, if I instead would have created a view on top of a landing zone table, if I get 50 more rows in the landing zone table, my view automatically would have 50 rows when I will compute it. So that's one good thing about view, is in reality, it always gives you the most fresh data, as well as you don't have to write the query again. 50 queries are right there, 50 lines are right there, and you can create a view. Now, something other databases don't offer, I guess other, like Redshift, I know offers this, but other regular, I don't know if SQL database, like a regular SQL Server database offers it or not, is something called materialized view. So what happens is, if you remember, view is something that get queried right there, right then, when you're querying it. So for example, this is 50 rows of SQL. I want the result of those 50 rows of SQL. I said, select all from this view. It gives me that table. But there's a processing time attached to it. That 50 lines might take 15 minutes to run. But I don't want that processing time. Now you're like, you can create a table Yes, I can create the table, but that will never refresh until and unless I say insert into, I create that table again. There's no way to refresh it. Materialized view comes in between a view, most fresh data, but the processing time is there, and a table where there's no refresh time, and processing time is really fast because it's right there. You can do it. What materialized view does is it queries the table in regular intervals. Just think about every 5 minutes, it queries the table again. So when I query the view, I have just 5 minutes old data, as well as it's faster than view because it's kind of there. It doesn't have to recreate the whole thing again when I query it. So it's faster in processing time, as well as the data is kind of fresh. So again, there's a balance in between those. So when you have such use cases where, you need faster and like your processing time is a lot bigger, or your data size is small, and aggregates takes a long time to calculate, you can just put it in a materialized view. So their data is relatively fresh, but your processing time is not bad as well. So this is one thing that Snowflake offers, called materialized views. Any questions on materialized views or tables? Okay, perfect. Now, I guess for tables, you can do show tables. So we already do show tables. One more thing that you can do is describe tables. And good part of describe table is it will give you column names, the data type of the column, the kind is a column, whether it can be null, is there a default value. So describe table can give you some more things about the table. While if you just want to see columns, there is something called show columns. And then it gives you a little more, like the data type is fixed, precision is 38, a little more information about your data with database name and all that. So that is your show tables, describe tables, show columns. So here what we are doing is we are kind of getting to know the table. So if, for example, you go into the system and you see some tables into your system, you can use these commands to figure out what's really in those tables. When it comes to table creation, again, we talked about it. It's pretty straightforward. You can use create table to do it. You can use create table. And one thing that I wanted to show you guys was the difference between if you use replace keyword and if not exist keyword. Can anybody guess what difference would it be if I create a table using replace keyword or if not exist keyword?
Sorry, can you repeat the question?
So I'm saying, so I can either create a table using create. So for example, I can create a table like this, create or replace table, and I'm creating a table like this. Or I can create a table like this where I'm doing create table if not exist. So you can see I changed replace to if not exist here. Can you guess what the difference would be?
In the first scenario, you're like you want it to be you want to create even if the table exists already, you want it to be replaced with a new table. And then the second scenario, you only want to create the table if it does not exist.
Perfect. Thank you very much. That was the right answer. So let's see this in action. So right now, how to create a table? I have this table, and if I see what this table is if I show table, no, let's not show table. Let's describe table. How to create a table? It has 4 columns. Let me run replace table. And you will see that I don't have any default setup right here, while there is a current timestamp default. Let's run it. And based on the logic, if I describe it, my default would be gone. You can see default is none because I'm replacing a table. Now, what about if I do if not exist? You can see that this table has 3 keys instead of 2. If I run it, it will still give me a happy remark that, statement is successful. But if I show table, describe table, and based on our concept, it should still have 2 keys rather than 3. You can see 2. While I ask it to make 3, but it's not 3 because I give if not exist keyword. These keywords are really, really useful when you are doing, like, you don't know, like if you have like thousands of tables, it's really, you might find it difficult to find certain table, and or you ran a script, because sometimes you keep running certain scripts. Adding these keywords make sure that you don't lose any data if you decided not to. So add if not exist keyword, and it will make sure that your table still is there if it already exists. While if you think that, I don't really care about data, add a replace keyword, and it will just make sure that happens. So those are the difference between those 2 keywords. There are a few more other keywords, and again, these are all SQL keywords, and those keywords are, you can see that, for example, so creating an empty table, we already did it, pretty straightforward, you just create it. What about if you want to create a new table, but you just want the new table to look like the old table, rather than have the same values? So there are 2 keywords that you can use. Like keyword means create the table like the other table, but don't copy the data over. On the other hand, clone keyword automatically means copy the data over. So again, in your scripts, you can think about, do I want to just create the table like the other one, or do I want to copy the data? And you can change your keyword and it will do automatically what you want to do. Or you can conditionally copy from a certain table. Here, you can see that create table if not exist, and select a certain column from this table to create this table. So it doesn't mean that you always have to clone it to make it look as same as the other one. You can conditionally select certain columns as well. So you have all these choices, and these choices, so I think these choices exist in all databases. So this is not, I don't think so. It's different for Snowflake, but it's something that you will use in your regular work, where you have to make those choices. Okay, I just want one column, I want the whole table, or I just want the table to look like this. We already, I think I didn't show you console way of creating a table. So let me just quickly go through that. Data, database. So in database, in schema, so let's say landing schema, create, and you can see standard as select, external, materialized view, standard view. So we have all these options to create it from console. Okay, let's see what else is there. Table modifications. Again, if you create a table, that doesn't mean that you're married to it. There is just no way to replace it. You're always allowed to replace tables or change their names or alter their columns. So for example, let's do a quick example of so this is how to create a table. I have this table, and this table right now has 2. Okay, that would work. So right now what I'm doing is I'm just inserting some values in the table. So I inserted 3 values. If I look into this, you can see there are 3 values in this table. And because I inserted on the exact same time, the update time get updated to that timestamp. Now, if I want to change the table name, I just want to show that there's no table exist with the rename, how to create a table rename. But now I'm changing the table name, and it's pretty simple, alter table, rename to this table. So right there, and now you will say this table will start existing, while how to create the table will stop existing. So again, and this is just one example of renaming it. You can add columns, you can rename columns, you can alter columns and all that. I see, Amanda, you unmuted yourself. Question? Oh, I guess no question.
Sorry, is there any reason why you're not making any primary keys on any of the tables?
Is there a reason why I'm not making any primary keys on any of the tables? This is just a very small teaser. I just like primary keys and all those topics are a little more deeper. And it's common to all databases. So I just don't want to do it in just 2 hours. So that's why I will just keep it very simple. It's all about Snowflake. So things that are different in Snowflake, that's what I want to do. Okay, any other questions? Okay, perfect. Dropping the table is pretty straightforward as well. Drop if exist, undrop if you want it again. Views, very similar, similar SQL, except now show tables in other than the, like instead of saying tables, we are saying views. Creating a view is very straightforward as a table as well. Dropping a view is very similar. Now, thinking about when to use materialized views and a regular view. So this is just a very quick and good way of deciding what you really need. So create materialized views when all of the following are true. And what are those things? The query results from the view don't change often. This almost always means that the underlying base table for the view doesn't change often, or at least the subset of the base table rows used in materialized does not change often. So because materialized view kind of loses the ability to give you the most freshest data, it's important to think about if the data, underlying data, is changing on your table. If it's changing, then don't make materialized views if it's changing really fast. If you know that it's going to change in an hour or 2 hours, you can go for materialized views and gain that processing speed that a simple view cannot give you. The result of the view are used often. Again, if a result of a view is used often, all the time, if for example, it takes 10 minutes to run, you will have to run it 10 minutes and wait for those results every time you use it. But materialized view gives you that faster processing power. And the query consume a lot of resources. Typically, this means that the query consume a lot of processing time or credits. And it can also mean that the query consume a lot of storage space for intermediate results. Use materialized view if the query runs for 10 minutes and because everything in Snowflake is charged, if it's running for 10 minutes, it's using a certain certain money, and it will cost you. So use materialized view if it takes a long time, so that you don't get charged every time you use a certain view. Now, use regular view again is just all those 3 lines, but the opposite. So if the results are changing often, use regular view because you want the freshest data. The results are not used often, so you don't really you don't care about the amount of processing time it takes, because once you query it, it's okay if it takes 10 minutes. I'm not going to use it again and again. Or the query is not resource intensive, so it doesn't take a lot of resource, or it doesn't cost a lot of money to process such query. Then you can just go ahead and use view because it doesn't matter how many times you run it. It won't matter. One more quick comparison of tables and views. There is something called cache. Cache is basically a really fast database. So you can see the speed is really fast, but it's a very expensive database or a way of storing data. Then you have materialized view, which is fast. The speed is fast because again, it's materialized, but it's expensive. Then you have table, which speed is okay because it's right there. When you call it, it's ready, and the cost is okay. While view has the low cost, but it's super slow because it's going to take the whole processing time it would need to run a query. So that's comparison on table and views. Any questions on table and views? And sorry, Amanda, I think that you have unmuted yourself, so we can hear anything. So yeah, perfect. Thank you.
Sorry.
Yeah, no, that's fine. Okay, good. Data types. Again, this is something, and I'm just some of the data, like you have seen data types in all the SQL databases. It's very similar concept. So I just want to touch, I just don't want to spend a lot of time. So here it is. All the data types that you see in SQL, Snowflake also have it. So you have integer data type, you have numeric data type. In numeric data type, so the difference between integer data type that is that it cannot have decimals, while numeric data type, you tell it how many decimals you want. So for example, this 2 tells you how many decimals you want. Varchar is just a string way of storing things. You can tell it how much length of a string you want to store. So for example, if the string contains 100 pieces or 100 letters, you can tell it 100 so that it doesn't have to automatically compute. But if it does, if you don't tell it, it will figure it out by itself. You just would get like it has to process it, so you will get charged for it. So it's always a good idea, if you know it, it's better to put it there. Boolean, yes and no. I'm hoping everybody would know what that is. Date, again, very straightforward. Timestamp is very straightforward. Now, one more component of Snowflake is a worksheet. So if you remember, I have these worksheets, which is basically a place where I can store my code and I can run it and it will give me results. In worksheets, you can see there are a few options. So you can see your databases, you can see hide objects or editor or results if you want. There's a charting option as well in Snowflake. So if you have a column or something that you want to quickly chart, you can chart it. But again, the visualizations are quite limited because that's not the use case for Snowflake. Charting, then you can download your results as CSV. You can see query details right here. It will tell you how much a column is filled and all that stuff. You can search for things. You can go to past history as well. So you can preview how it was looking 2 seconds ago, past version. You can preview it. Okay, this is what I was changing on this. This is what I was running. So all the history is stored as well, which is quite handy. If you, for example, you ran something and then you raised it and you're like, oh, I wanted it again, you can just go on history to do it. Now, Snowflake has something called roles. I guess it's coming up in like 2 seconds, so I won't touch it right now. I can filter it too. I can tell that, you know, whenever I want a certain value, give it in a bucket so that all the results would be in a bucket. Like would not say this day, this week, this month. It will come grouped. As well, I can add certain filters. So it's just like, for example, sometimes what happened, and this happened a lot in the development environment, that you automatically want to set a limit so that the person does not keep on querying like all the rows. So like, for example, if some table have 100 rows, in development, he might not need 100 rows, he just need 5 rows, but adding limit equals to 100 sometimes get very repetitive, so people skip it. Setting a filter makes sure that it's always going to carry that limit equals to 5 or things like that. You can import SQL file into Snowflake. So for example, if you have a huge SQL file that you want to run on Snowflake, it's very easy to import. You can put into different folders, and basically this worksheet give you some options to interact with the console, as well as do some easy things as well in a very, very fast way. So that is your console. The two last things that I will touch about Snowflake is one is called warehouse. So Snowflake is a data warehouse. So don't confuse that concept to a warehouse. What warehouse means is your compute power. Something that different databases might not provide, and by different databases, I mean on-prem databases might not provide, is Snowflake. It's very, very easy to change the warehouse size. So in reality, what warehouse is the brain of Snowflake. So if you give an extra small warehouse, and I'm just making it up, 100 rows, it might take 1 minute to do it. But a large warehouse might take 1 second because the brain is that much more bigger. Now, and that can really help you increase your queries. Right now, I just have one warehouse, which is extra small, but it's pretty straightforward to make other warehouses. So you can just say create warehouses. You can give the name of the warehouse. You can say the size of warehouse. So this is large. Now, there are two options also with the warehouse. One is called auto suspend and the other one is called auto resume. Now, when this brain is working, it's charging you money because everything in Snowflake is charged. But they give you an option so that you can auto suspend it if it's not being used. What it means is that if I leave this as it is for 10 minutes, you will see that it will detach the warehouse from the Snowflake instance so that I don't get charged for it. But as soon as I'm ready and I query, I don't have to attach that warehouse again. The auto resume option would attach it automatically. So this is how you can save some money in Snowflake by making sure that it's auto suspend and auto resume. Very simple way of creating warehouses. And again, there's a console way of doing it too. So if I go data, if I go, the warehouses would be, so it's databases, schema, because I have to find where the warehouses are, worksheet, dashboards, activity. No, I think it's admin. Yes, this is the warehouse. So you can just say, this is the name, and each warehouses have credits and each credit has a certain money attached to it. That's how you can figure out money, but this is how using a console where you can make a warehouse. So in summary, warehouse is just the brain. If your query is taking a lot of time, attach a bigger warehouse, it will run faster. That's all the warehouse is for Snowflake. Role, again, the database management system comes with a role, and Snowflake has roles. What it means is, for example, there are certain tables that you want, like you have a marketing analyst. You don't want to share your sales data with it because he's a marketing analyst. You can create a role saying marketing analyst and give it permission to certain tables. And then if you hire 50 marketing analysts, you just have to attach the role to the user. User is an individual account, which each marketing analyst would have. Role is a role. Like, for example, there can be there can be 100 marketing analysts. So if you attach the role, they will automatically get permissions for certain tables that you defined in the role. So just role is something that makes your life very, very easy because you don't have to redo it for every single user. In order to create roles, I think it's an admin activity again, and user and roles. And you can see right now, I have 4 users, and these are the roles that I have. And I didn't create all of these roles. These are the roles that Snowflake automatically gives you. So account admin would have all the access, while security admin have security accesses but might not be able to look into tables. So these roles come in Snowflake, and you can create as many roles or as different roles as you want in Snowflake. So Snowflake gives you all those options as well. Those were the roles. Perfect. Any questions about the components of Snowflake? Okay, and I can see that we have just half an hour left.
I have a quick question about the Snowflake concept. When you have so many databases in the warehouse environment, so many, how do you control for security? How do you ensure that the right person gets access to the right the warehouse? Is there a way to do that here? Or?
Yeah, so you define a role. You say, for example, in my example, think about there are databases like Walmart has a database. Safeway has a database.
Okay, so the roles which follows the user, I guess. Okay, and then you decide what. Okay, got it.
Yeah, so I can say Walmart role and give that user that role and done.
But I thought those roles controlled the access to tables, not the access to the warehouses.
They can do that as well.
Okay, thank you.
Yeah. Okay, no Snowflake. Now, the question is, why is Snowflake so much, I would say, cooler than the databases that we had or on-prem databases? What can Snowflake provide different? And when I say what can Snowflake provide different, it's not just Snowflake. All the clouds, AWS, GCP, and Azure also provide these capabilities. And what are these capabilities? So a very revolutionary idea that came in with cloud is that you can detach database storage and the warehouse computing power. You can decouple them. And why is that useful? Firstly, what it means to decouple them. If you think about your CPU or in you have a laptop in your house. If you want to increase the computing power of that laptop, you have to open it up. You have to install a new RAM to increase the computing power. And that computing power, your laptop comes with a certain amount of storage. So if you want to build a new laptop, what you will do is you will put more RAM as well as more storage, because you're like, I will use more RAM, let's get more storage as well. Otherwise, I have to open my laptop again. This was one of the problems with the on-premise, or when the companies have their own data centers, is that they have to attach the compute and storage together. Increasing compute automatically would mean increasing storage, because why won't you do it? And this system comes with more storage and more compute, so you increase your storage, meaning you increase your compute as well. What cloud did is they're like, if you need less storage, you don't need more storage. Let me give you less storage, but if you need more compute power, I can give you more compute power. So that's what is the decoupling mechanism of storage and compute. And that makes life so much easier, because you don't have to waste money on storage if you don't need it. You just want faster processing, just get more compute. Or if you need more storage and you don't need any compute, you just detach your, what in a Snowflake called a warehouse, the brain of Snowflake. You can just detach it. Now you're not paying for that compute. Somebody else can use it, but you have all the storage with you. So this decoupling really makes users save money, number one. And number second, it opened up so much opportunities, because if you want more compute, you don't have to own a huge big data center for it. Just ask for more compute to the cloud and they will provide you, because they already own that huge compute. They can just provide it to you. So this decoupling mechanism was really revolutionary. And this decoupling comes with one more decoupling, whereas like the security is a complete different layer. The optimizer is a different layer. They are not attached. So they are not attached to compute and database storage. They are just separate things, so that if you want to work on a certain thing, you can do it. Like you don't have to get married to a certain certain compute or certain storage. Snowflake storage. Now you have freedom to choose whichever cloud you want to use. So you can either do Snowflake managed, you can do S3, you can do Microsoft Azure, and I'm pretty sure they have GCP now as well. How is this different from a OLTP? So again, in the starting, we talked about OLAP and OLTP. So how are those things different? So OLTP, which is the database which we use in our banking system or any transaction system like CRM, like any other database, it's basically a row store. And the reason why it's a row store, what it means is it takes a row or it stores in terms of rows. What it means is, for example, if there's a bank account, my bank account, it has a name and my bank account balance. So for example, if I have $50, it will store Hamza and $50. Now, for example, somebody else, for example, Chris has a bank account. It will store Chris and have $500, for example. Every time you add a new name, for example, if you add Yuzu or Amanda, you have to give it a balance because they kind of come together. The name always come together with a balance. That is a row store. In a column store, on the other hand, columns are stored together. So you can see that here ID, name, city, country, order number, they have to come together. They're stored in a same level or stored together. While in a column store, ID, the whole column is stored separately. The whole column is stored together, while the whole name column is stored together. Whole city column is stored together. And let's think about why would that be useful when it comes to analysis. So row store is for transactions, column store is for analysis. How many times have we asked for a max value of sales? Which customer took the most sales? Now, if a certain database has to go through rows, it has to rate every single row. Take a number of how many order does that customer did. Go to the next column, read the row again. And when he is reading the customer name, he has to read the customer city as well, which is not really needed. On the other hand, if we have a column store, it can just figure out who ordered the most, take that value, and then now start to read the row of that customer. So that's why OLAP is so much more faster and cheaper when it comes to analysis, because it moves through columns and we usually do calculations on columns. On the other hand, it is bad for updates because if you're changing one column, it doesn't mean that you have to change the adjacent column for the same record. But if you have to do that, wrong case, it can only move in columns. So what it will do is it will go to a certain column, go to that place, then jump onto the same other column, go to that place, and then change it. So you can see how much more time it would take to do that. While in row store, it will just go to that column and update it. So that's why Snowflake is a good OLAP system or analysis system rather than a transaction system. Again, everything has a price, and the brain, which is the warehouse in Snowflake, you can see extra small has 1 credit usage per hour, and 1 credit is about 0.0056 per second. So you can see if you use extra large database, it will give you that much more dollars. So bigger brain means more dollars, and everything is credits. So, and this is how it's getting calculated. Okay, any questions about Snowflake? What's inside Snowflake?
You said the column store, right?
Yeah.
It makes sense to have the single column store, but I'm sure that there's a pointer associated with each column value. Like if you have in a column store, there are 50 different values for that column, right? It's got to be able to associate say column value number 4 with some other person's value number 4. Does it make sense? So it won't just be storing a single value for the column. There must be a pointer or some sort of key associated with each of the column values, right?
Right. So it can always see that this is on row 4, and it can go to row 4 to each of those columns. So it has those keys as well. But it's basically, think about snake and ladders. If you remember, snake and ladders go in column. So that is a row store. Sorry, it goes into rows. That's a row store if you are just moving one unit at a time. But if you use ladders, it's a column store. So that's the only difference, is that it can move vertically versus horizontally. But there are keys attached to both of them. Yes, you're right. So if there's a row 4 has a certain value in a certain column, it can say what other column row 4 is, and it can attach it. Hopefully that makes sense. Hopefully I answered your question.
Yes, it does. Thanks.
Okay. I think there's no question. I have 20 minutes left, so I will speed up a little. Okay, again, SnowSQL, we were on the console. We did a lot of stuff on console. We can write SQL on console. But what about if you want to reach to SnowSQL using using a virtual machine or something? So SnowSQL, if you click here, you will go to its documentations, and the way of running SnowSQL on a terminal is called SnowSQL. Snowflake on a terminal is called SnowSQL. And I think if you go connecting to Snowflake, there is a SnowSQL client, and you can basically install SnowSQL right here, and it will tell you how to install things. SnowSQL download page, it will give you SnowSQL for Linux, for Mac OS, and for Windows. So this is just a terminal way of controlling Snowflake. If you see SnowSQL, you can see the link below, SCF repo. And these are just I already installed it to save time. But if you install these, go through these commands, you can download SnowSQL. So I already have SnowSQL. I'm just going to open my VS Code, and just to prove that I have it, if I do SnowSQL version, there you go. It's right there, and I have it. Now let's quickly go. Okay, there's a very quick note about Mac. When you install SnowSQL for Mac works with ZSH file, but SnowSQL wants to find bash file. So you will see an error. It won't work. So make sure you will give it the right direction, which is just to write this line in your ZSHRC file, and then it will start working. So just for Mac users, you have to do this extra step. Okay, let's quickly connect to my Snowflake account. So if I go to my Snowflake account, and here are the 2 key things that you have to remember in the Snowflake account. One is this region and the account name. Now, if I go to my can you see my VS Code? I just want to make sure that I shared the screen right. Anybody confirm?
Yeah, we can see.
Perfect. Thank you. Okay, so if I go SnowSQL -A, that's my account name. I will copy paste it, but I have to put it a little differently. So your MK81553 comes before, and then there is a dot. This is your account name. Now, if you remember, my username was I already created a different username. So in reality, what your username is basically sitting right there, or the username that you used to log in. I think my profile should give me my username right there. This is your username. You know what? Let me use this account instead, just to show you guys how to connect it. So, and I will give my username, which is mhamza the 3rd, 1994. It's going to ask me for my okay, incorrect username, failed to connect, incorrect user or password. Make sure my name is right. Profile. Or I think it might be going directly. Let me quickly go back. Try it again. I'm pretty sure this is right. Okay, it won't connect, and I will show you why. So the thing is that here I'm giving my user name, but it gets really tiring to keep giving it. So there is a config way or a way that it can automatically catch all that. And in order to do that, what you have to do is let's go to home. So this is home. So ls-a. Once you install SnowSQL, what you will see is you will have something called .snowsql right there, right here. So you have a folder made .snowsql. If you go into that folder, there is a config file .snowsql. And if I ls, you can see that there's a config file. I can nano that file. And if I go here, I already have these account names put in to save time, but I think those are the reason why it wasn't working. So I will just take it out for now, just to show you that you can directly connect. Yes. Okay. Now if I do SnowSQL, it should ask me for my password. Perfect. Oh, wrong password.
So what was the reason that it didn't work before? What was the reason?
Because I had something set up as default.
Okay.
So it was catching that, and it was like, okay, your default is wrong. And that's why it wasn't working. But I commented it out so that now I can give it my credentials.
Okay.
There you go. It's connected. I'm in SnowSQL now. I'm basically my SQL. Basically, I am in my what we saw in console. So like, for example, let's use the warehouse demo. That's my brain. Now you can see it. And let me just quickly show you that I am in. I can show you by, like, if I look into my data, let's see what databases I have. So in DemoDB, I have all these schemas. Or in Enterprise Zone, I have table 1. So let's go for that table 1 in console. So database that I'm using is use database. And the database I'm using is DemoDB. There it goes. The schema that I'm using is, what schema was it? Enterprise Zone. There you go. And then let's do show tables. And you can see table 1 is in there. So perfect. I am in the right place. Okay, let's get exited out. Perfect. Now, here I connected using my account name and username. But the problem is it gets really old really quickly to keep writing these things whenever you connect to SnowSQL. So there's a config way to do it. What config way means, there is a way to store it somewhere so that whenever you connect with SnowSQL, it knows exactly how you're connecting. And that's through the config file. So something that I just commented out, now I will be commenting it again. Like I will be removing comments so that it can get connected. So I have different user. This is for WCD demo. And so this is where you put all of your default values. And it says warning, warning. And the warning is this password that I put it like this, but it won't work because you have to give it a text like a real password, but I don't want to reveal my password right now. That's why I just put asterisk there. But what I'm going to do is I'm going to stop sharing my screen, put my real password, and then we will see how it can connect automatically without giving any more information. So let me stop sharing.
Are you on a Mac or PC? Or Linux?
This is Linux.
Oh, you're Linux, okay.
Yeah.
In the Mac terminal window.
Say that again.
In the Mac terminal window, so I wasn't sure where you were.
So I'm on VS Code, so it's connected to Linux, but it's a Windows machine. But I have a virtual machine running,
Okay.
and that's why you cannot see it because I just have it in the background. But the VS Code itself is Linux, while the machine is Windows. Okay. I put my passwords in, so I'm just going to share my screen again. Okay, now what's going to happen is when I say SnowSQL, it should automatically go into my account. There you go. I don't really have to give it anything. So because I put all the information there, so this is possible to do. One more quick thing. Oh, I have 10 minutes. Wow. This is taking a lot of time. Okay, let's quickly go and load some data into Snowflake, because in the end, you want to load data into Snowflake. So that's your goal. So in order to load data into Snowflake, what you have to do is there are 2 steps that you always have to do. The one step is to stage it, which means your data files will go into a staging area. And the reason why there is a staging area, so that if you want to change something into your files, you have an option to do it, and then it gets inserted into table. So there is a put command that put it into staging area, and then there is a copy into command that put it into table. There are different type of stages. So there are user stages, like for example, there's a stage attached to Hamza, so that Hamza can put files into it. And there are named stages which are used, for example, if you're putting data from S3, you will create a stage for S3 so that whenever you put a file into S3, it automatically goes to that stage and it's available for you. And then you can load that file into your Snowflake instance. So there is a user stage and a named stage. We will quickly go through a demo of each. Now, the first demo is, the first thing is, I will show you how to put things into a staging area, then copy into a table. And then if I will have to be really, really fast, but then I will show how I can directly put things through S3 by building an integration between S3 and Snowflake. Okay, let's do the first thing quickly. So if I go here, okay, now here I do, let's refresh it. Okay, I do have few databases, so let's create a new. So here what I'm trying to do is my Linux machine or my terminal have a file set in. Just to show you guys, CD, let's go. CD, no, ls. So it should be sitting in my download. So CD down, CD downloads.
Capital D.
Sorry?
Capital D. Downloads, capital D.
Oh, capital D. Thank you. Downloads. Thank you. ls. And you can see that there is a cities file here. Let me just quickly show you what it is. So cat cities.cvs. So basically what it is there is some sort of ID attached to it, city ID, and then there is a city. So it's very simple. What I really want to do is to put this file into Snowflake. So how would I do it? I already have SnowSQL. So what I'm going to do is first I will have to create a database. So sorry, a table that can accept it. So that's what I'm doing. Let me just quickly drop this database. If it exists, let's create it again. Let's create a schema. This is just, I am making a place so that I can put that data. Here I'm creating a table called enterprise.city, which has city ID and city name, very similar to the data we have. So there you go. It created a table. Now in Walmart dev, I have a table called city. Now, right now, this table has nothing. Just to prove that it has nothing, I can just do it like this, and you can see it has nothing. I just created it. This is the command that I have to run in SnowSQL, which is right here. And what it's doing is I made a connection called demo. It's like I'm just using a connection for it. In my configuration file, there's a place for connection. That's where I put this connection in. And I'm just going to use a very simple command, put file cities.cv. That means use this file, which is sitting in my folder, and put it into my stage. And my stage is always tilde and @ There you go. As soon as I click yes, it's going to tell me it's there, it's ready. Now, if I go back to my if I list how my stage looked like, you will see there was cities sitting there now. And then it's super simple, copy into that table from my stage, and you will see that it has added GZ in front of it right here. The reason is it just compressed it. So if I do this, it's telling me that there are 320 rows loaded. And if I check my city, this data is here. Perfect. That is how you download the data from a file in your local system. You can put it in Snowflake using this. Now, what about if that file is not in your system? Usually you store files in S3 or a storage system like S3. How would we do that then? How will we download data from S3? It's a little bit more complicated process. So let me just, I'm going to go through it really fast, but in reality, what I am doing is basically what I will do is I will make a S3 bucket. And on that S3 bucket, I will create a policy saying, I will create something that should be able to access that bucket because Snowflake needs to access that bucket. So I will make a policy and a role that will make sure that anything that is attached, that this role is attached to, should be able to access S3 bucket. Once I do that, I will build the integration in Snowflake and a stage of that integration. And once I do that, you will see that I put a file into S3 and it will come up in Snowflake, in a Snowflake stage. Okay, so that's the main idea, but how to do it is what I'm going to show you right now. Okay, let's create a bucket with the name Snowflake stage bucket. So let me go to my, so let's get rid of this. Let's go to my AWS. And let's quickly create a bucket. Let's put a name. Instead of your name, let me put my name. Hamza right there. Everything looks good. And I create a bucket. Perfect. You will see that there's a bucket. It's empty because I just created it, didn't put anything. The next step is to create a IAM policy that have access to that bucket. So I will go to IAM. And let me go to policies and let me create a policy. And I will create a policy using JSON. I already have a script ready. And I think you have access to these nodes, so you can use this script. What this script is doing is, okay, let me copy it. Let me put it there. And I will quickly explain what this script is doing. What it's doing is, and I will change my bucket name here. Your name is Hamza. It's saying anything that is inside this bucket, allow to get that object or delete that object or put that object. And so that's anything that's inside that bucket, and that's where this static comes in. On the other hand, for this bucket, let it list its content and get its location. So for bucket, anything, so this is a policy, and I will attach this policy to a role and anything, and then I will give that role to Snowflake so that Snowflake can do these actions. So that's the whole goal here that I'm trying to pursue. So Snowflake stage policy, I will name my AM like that. Again, no description, not a good idea, not the best practice. I'm just doing it because I don't have enough time.
Did Snowflake provide the script template, or did you make it from scratch?
These templates is in the Snowflake documentations. They should be in the Snowflake documentation. They're just, yeah, it should be in the Snowflake documentation. So you should be able to, and you can access this. You should have access to the lecture notes, so you can access it as well. Okay, so I did a policy, and now I want to attach this policy to a role. So I will go to roles, and I will create a role. And I will create a role, and this is all written in lecture notes. So you have to go to AWS account, you have to go here, and you have to give external ID. For now, I'm giving external ID as a placeholder because Snowflake is going to give me this external ID. Here I'm saying anybody who has this role, and I will tell who will have this role, is able to access S3. So that was the goal here. You can see my policies are made right here. It's sorry, I have to attach this policy to the role. So attach this policy to the role. Okay, now what's the next step? Attach policy and copy the URL. So I will just give a role name as Snowflake stage bucket. Snowflake stage bucket, there you go, create a role. Looks good. You can see that the Snowflake stage bucket role has been created. Now it's time to start doing things in Snowflake. So I will just take this integration, which is a Snowflake integration. Oh, I think I should have it right here. Okay, so in order to create Snowflake integration, let me create a brand new database. I'm just going to drop this database and create it again. And I'm going to use that database. I'm going to create brand new schema, enterprise schema, because in schema, there would be the storage integration. And this is how I'm creating the integration. Pretty straightforward. It's in Snowflake documentations, storage, the integration name would be this. It's external stage, S3, it's enabled, so anybody can use it. And I would need ARN for my role. So if I go back here and go to my role, you will see that there's an ARN. I will just copy it and I will put it right there. Perfect. And my name of my bucket is S3 Snowflake stage bucket Hamza. If you remember, that's what my S3 bucket name was. I'm going to create that bucket. And then I'm going to describe this integration. So it will give me certain things. That is basically describing this integration. Now, in order to connect it right, I have to go back to the role and put these values in. So for this role, if I go to trust relationship, I have to put this user value in. So let me copy it. And let me put it right here. And again, this is all in documentations. Oh, this didn't got copied. Let me copy it again, put it in a notepad, and let's see, let's put it right there, and then get the integration as well. External ID, sorry. Put it in notepad as well. There you go. Okay. Now let's copy it from here, put it right there. Oh, I have to edit it. Put it right there. Here you go. and put this right here, which is, this is the placeholder I put. I'm going to put it right there. Okay, update policy. Good. Now the policy should have all the things that it need. So I will use the exact same database. I'm just putting, I'm just using Walmart Dev and Enterprise. I created a file format. So whenever you're putting something in Snowflake, it's always a good idea to make a file format to tell it what it's expecting. So file format, I will give it a type and a field delimiter, saying that anything it's in this field should be use comma, as well as it's a CSV file. So that is what the file name is, file format is. And I will make sure that my schema is allowed to create a stage. As account admin, I have access to create stage on an enterprise schema. So this is where the security part is coming in, that I'm allowing myself to do all these changes. Now I will create a stage, and stage is going to use storage integration, which I already created. The URL it's looking for is this S3 bucket, and the file format is this. There you go, stage is created. Now, just to make sure that this stage have nothing right now, you can see there is nothing in this stage because my S3 bucket has nothing. So if I put something in my S3 bucket, this stage should have access to that. So if I go into my downloads, there is this city that I want to put there. So I will go here and you put this city right there. I will upload it. Okay, it's in there. Time to check if my stage will get it. There you go. You can see my stage get it. So see how automatically loading something in S3 gives the access to the stage so that it can then be downloaded into Snowflake. I will just truncate my table because my table was had a lot of stuff in it, just to make sure. I think I already dropped the schema. It does not exist. Oh, okay. I have to make the table again. Let me just quickly make a table. So create table, right? Database, enterprise, and I create a table so that I can put this city into a table. So if I look for this table, there's nothing in there, but now I'm copy into using the stage, which is S3 right now. There you go. You can see 320 rows are downloaded, and we basically got the whole thing from S3. Sorry, the last part was really fast because I'm already over 7 minutes. I'm really, really sorry for that. But just wanted to show you that it's possible to directly do it from S3. Any questions about this